let's jump right in. So on Thursday, I'm actually going to move to the side before I jump into that. On Thursday, we finished off we just started the idea of similar. So we first finished off congruency last week, and then on the Thursday, we started similarity. So we just brought in this idea of similarity. Okay, so before I do anything, I actually just want us to quickly try and break up those two thoughts so that we can see what the actual difference is before we jump into some more sort of tricky questions with regards to similarity today. Okay, so I'm just gonna quickly make a little division over here. Oh, just these lines are just like not being my friend today. It's gonna have to do, guys, I'm sorry. Okay, we are going to start with congruency, because that was where we started our lessons. Okay, when we're talking about congruency, what symbol do we use? What is our symbol for congruency? And if you're struggling to write it in the chat, you can just put your hand up. There we go. Burlington, what is our symbol for congruency?
1, 2, 3 lines. Like
good.
Lines.
Good. Yeah, we have 3 lines that are horizontal. Perfect. Okay, so our congruency symbol, let me take brackets away. Oh no, I just got rid of this beautiful line I spent so long drawing. That's fine, that line's actually better. Okay, so congruency are 3 horizontal lines like that. Who can give me a very simple sentence to explain what congruency is? What does it mean if 2 triangles are congruent? What does it mean? Think about it in as simple a way as possible and write it in the chat for me. What does it mean for 2 triangles to be congruent? Okay, I like it. Chilo, what's your answer here?
For 2 triangles to be congruent, right? They're exactly the same, you know, perfect. Same angle, same size, everything.
Perfect. They are exactly the same. Okay, so if you cut the one out of a piece of paper and you cut the other one out of a piece of paper, they would fit on top of each other perfectly. They are exactly the same in every way. Okay, for congruency, we have got 4 different cases of congruency. So basically, we have 4 ways to prove that 2 triangles are congruent to each other. What are those 4 cases of congruency? RHS, good. SAS, good. SAA, yes. SSS, perfect. Oh, you guys are so smart, I love it. Okay, RHS just means that if we have 2 triangles, they both have a right angle. Okay, so that's my R. They both have a right angle. They both have the hypotenuse that has been given to you and another side. Okay, RHS. Then we have SAS. So we have 2 triangles. They've given you one side that's the same. They've given you another side that's the same. And they've given you an angle. And that angle is in between our 2 sides. SAA. They've given you a side. There we go. Yeah, exactly. The holiday spirit has gotten into my screen. Okay, so there's a side that's the same and then 2 angles. Okay, and they have to be corresponding to each other. And then we have SSS. So one side, another side, and a third side. Okay, so that is showing that our 2 triangles would be corresponding in different ways and they would be congruent to each other. Okay. Our next thing that we spoke about, and this is the one we just started talking about on Thursday, is similarity. Okay. Similarity has a symbol very similar to congruency, except there are 3 vertical lines, not horizontal. All right. What does it mean for 2 triangles to be similar to each other? So now just be careful. because it's different from congruency. What does it mean for two triangles to be similar to each other? Good, good. They have the same angles. Okay. Same angles. And I need to know something else. I need to know something about their sides. They differ in size. I'm looking for a very specific word here, Prosper. See if you can try and read my mind. There we go. P, we read my mind. Okay. The sides are in proportion. Beautiful. Okay. Okay, we have two cases to prove that triangles are similar. What are those two cases? What are those two cases? Good. There we go, sides in prop. Perfect. Okay. All right. Now, in order for me to prove AAA, I have to be given two triangles. I have to be given, so those two angles are the same as each other. Okay, so there's one of my angles. Those two angles are the same as each other. And those two angles are the same as each other. So all of my angles have a corresponding angle that they're equal to. So all three angles in this triangle equal all three angles in that triangle. Then I can use AAA. All right. Sides in proportion. In order for me to use sides in proportion, I have to be given all three sides. Can you say equiangular? So be careful, Prosper, because equiangular actually means that all of our angles are 60 degrees. It means that all of our angles are the same as each other within a triangle, not that they are the same as two different triangles. So equiangular actually is talking about an isosceles triangle. Not isosceles, equilateral. Sorry about that. Okay, sides in proportion, I need to be given all three sides. And I need to be able to prove that like 2 times 2 gives me 4. 2 times 2 gives me 4. 3 times 2 gives me 6. So I need to prove that if I multiply all of my sides on the left-hand side by the same number, if I multiply all of these numbers by 2, I'm going to get the numbers on the right-hand side. Then I can prove that the sides are in proportion. Okay, so this is just a very, very, very summarized version of these two topics. These two topics get really big as we move into grade 11 and grade 12. So understanding these base concepts is super, super important. The one thing that always comes up that your teachers will purposefully try and trick you with, okay, is this guy over here. When you try and prove that things are congruent, for some reason, our brain wants to use AAA as a reason, because you're thinking if all the angles are the same, then my triangles are the same. Okay, but remember, if the angles are the same, they could be congruent, yes, but they could also be similar. Okay, so AAA is not a reason for congruency. If the only thing you can prove is AAA, then you can only prove that those triangles are similar. You cannot prove that they are congruent. Okay. Does anyone have any questions about the notes that is currently on the board? This is your time to ask. And otherwise, I recommend taking a screenshot or a photo of some kind before we move into some questions. Okay, cool. Oh, yes, how can I help?
Can I just ask, when the sides are like given a measurement, right? Do we need to write the reason SSA or SSS, or we could just say given as the answer? Because
So
it's already given. triangle.
It depends on how the question was asked to you. If it was like a 1-mark question and it said, are these triangles congruent? And if they are congruent, give a reason. You could just say this triangle is congruent to this triangle because of SSS. If they ask you to prove that this triangle is congruent to this one, then you would have to state each thing. So you would say this side equals this side given, this side equals this side given, this side equals this side given.
Oh.
Therefore, they are congruent.
Okay.
Makes
Okay,
sense?
thank you. Yes.
All right. Cool. All right, let's jump into some similarity. So I want you to think about this question. Is SSA a reason? So SSA, essentially SSA is this guy over here, okay? And the only reason I try and suggest you write it as SAS instead of SSA is so that you remember that the angle has to be between our two sides. It has to be sandwiched between our two sides. That's the only reason I recommend you write it as SAS. You absolutely can write it as SSA. That's the reason I write it as SAS. Okay. All right. I want you to have a look at these two triangles, and no problem. I want you to think about the trap that I set for you on Thursday, and I want you to not fall for that trap today. I want you to think about what type of triangles you're looking at here. Think about what that means for the angles. So try and pull on some of your geometry knowledge. And I want you to eventually give me a sentence on which triangle is similar to which triangle. Make sure that your letters are in the right order. Good, Anna, that's a great start. And once you've gotten that, I'd like you to give me the value of X. So Burlington, just be careful here. With our sides being in proportion, okay, I actually think this is a good time for me to chat about it. Because this is an isosceles triangle, we can see that that's 4 centimeters, right? And we can see that this is 16 centimeters. Cool. But we haven't been given this. And so because we haven't been given all 3 sides, we actually can't use the reason sides in proportion, but we can use something else. I just want you to think about the type of triangle you're working with. That might help. Good, Nico. Yes. Okay, so now guys, be careful with the SAS that's coming in here. SAS is a reason for congruency. It is not a reason for similarity. Okay, so if we're looking at these two triangles, we can see that the one triangle is much bigger than the other triangle. All right, that means that these two triangles are definitely not congruent, which means we won't be able to use the word SAS. Okay, and just think about it. This is a 1 line, it's 4 centimeters. This is a 2 line and it's 16 centimeters. So this side is not the same as this side. So just be careful with things like that. But remember, making mistakes is good. That's how we learn. Okay, good. I'm liking the AAA that's coming through. Good. Sum of angles in a triangle. I like it. Try and write me your sentence of which 2 triangles are similar to each other. So think about your 2 different angles. Great. Okay, cool. I'm seeing some good things happening here. So let's just have a chat about this. In our blue triangle here on the left, okay, we can see it's an isosceles triangle, and that means that our base angles are the same as each other. That reason is angles opposite equal sides. Okay, so because this angle here is 55 degrees, that means that this angle is also going to be 55 degrees. Okay, if we then think about our angles in a triangle, if we say 180 degrees minus 55, we are going to get 70 degrees. So that means angle A is going to be 70 degrees. Okay, now let's look at our yellow triangle. We know that this is 70, and we know that this angle and this angle are the same as each other. Okay, so I can say 180 minus 70 is going to give me 110. That means that those two angles together have to give me 110 degrees. So if I want to know just one of them, I'm going to divide that by 2, and I'm going to see that they are each 55 degrees. Okay. Once I've done that, it's very easy to see that these two triangles are definitely similar because they have the same angles as each other. So then I can write my sentence. So I can say triangle ABC is similar to triangle DTP because of AAA. And then I just need to find my X. Okay, so if I look here, how did I get from 4 to 16? I said 4 times 4 gives me 16. So then if I'm looking here, I could say, well, 5 times 4 is going to give me 20. Okay. Can you give me an idea of how this question went? Remember, if you are embarrassed in any way, you're welcome to send a direct message, but just let me know how we're doing with this. And if you didn't understand it, but you understand it now, that's also 100% fine. So just give me an idea of where your heads are at right now.
Yes, my peeps, let's see. Anna, we can see that hand up. Yebo, you good. What about all the 39 people?
Good, makes sense. I'm glad.
Nice, Daria.
Burlington, yes, this is a question. Is it a
Question.
okay?
How did you get? So in angle. So we used angle. So right here we said that angle is 70, that angle is B is 55. So the I'm confused with the divide by 2.
By this over here?
Yeah.
Okay. So when we've taken the 180 minus 70, okay, so we've minus this angle over here. That leaves us with 110 degrees. Okay, so that means between this angle and this angle, they have to be 110 degrees. But we also know, because it's an isosceles triangle, that those two have to be the same as each other. And so we're allowed to just say 110 divided by 2, because there's going to be two angles that will be identical. And that gives us the 55 and the 55.
No, are we allowed to use this in like all circumstances that we get?
Well, it depends. So if we have to do a proof, we would still show all of these steps, but we would have to write reasons as we go.
Okay, ma'am. Thank you.
Okay, but we'll get to that. We'll get to proofs today. Oh, good. I'm glad it's helping. Okay, so this is just to sort of remind ourselves what similar triangles look like. I'm going to talk you through a proper similar proof now, and then we'll see what our time is like. We might have to jump to Brian, and then we'll go over some extra proofs after that. Okay. So when we are proving that triangles are similar to each other, I'm trying to help those of you who are on your cell phones. Hopefully this works. Okay. We follow the exact same format that we do for congruency. So we start with an introduction. We have a body where we have 3 reasons, and then we have our conclusion. Okay, so we set it up exactly the same as with congruency. In our introduction, all we are doing is we are talking about which 2 triangles we are discussing. Okay, so in our first line, I'm saying in triangle ABE, which is my blue triangle, and triangle CDE. Okay, so all I've done in that first line is say which triangles they are. That's it. Okay. Step 1. Hannah, at this point, if you wrote DCE, it would be fine. It won't be fine in our conclusion, but in your introduction, it would be fine. Okay, then we're going to get into the body of it. Okay, let's start. Here is angle A. What is angle A equal to? Have a look. Which angle in our green triangle is angle A equal to? And what would our reason for that be? Go to Pue. What's our reason for that? Good. Okay, this is why our geometry comes to help us. Okay, so we're going to say angle A is equal to angle C because of alt angles when AB is parallel to CD. Okay, so those two angles are equal to each other. All right, that's step one. Step two. I'm trying to find B. That's this angle over here. What is B equal to? Good. B is equal to D. And again, it's because of alt angles, because AB is parallel to CD. Okay. Now we're looking at this angle over here, which is AEB. Now you could say that it's equal to this angle because of vertically opposite angles. You absolutely can. But when we do similar triangles, we only have to use our brain for the first two reasons. That's when we have to use our brain. For the third reason, we get to just do a little bit of a cop-out, okay? We can just write what our third angle is. So I'm going to write angle DEC. That's my third angle. And then I'm allowed to just say sum of angles in a triangle. So what that's saying is that all of my angles in my triangle have to equal 180 degrees. So if two of my angles are the same as each other, then the third one has to be the same because they have to equal 180 degrees. Okay, so we're allowed to use this reason every single time as our third reason for proving similarity. It's like our easy pass. This is this reason every time for reason 3. Okay. Then in our last step, we're just writing our conclusion. Okay, now this is the step where it's important for us to get the angles that are the same as each other. Okay, so angle A was the same as angle C. So we're going to write that first. Angle B is the same as angle D, and then angle E is the same as angle E. And our reason is A. And that is our full proof. That is a full similarity proof. If you have questions, please ask. If you need clarification, please ask. If you're feeling 100% and you know what's going on, let me know. But tell me what's going on. Lenumta, how can I help?
Hi, ma'am. For this particular example, ma'am, for E, could you say that E1 equals E2, for example, because vertically opposite? Or do you have to say?
No, you can definitely say that. I'm just saying when we get to our third one, you don't have to use your brain. You can always just use the rule sum of angles in a triangle. But
Yes,
you absolutely could have said vertically opposite angles.
Okay, thank you, ma'am.
Sure. Why is it? It's vertically opposite because here's our bow tie, that little X, and those two angles are opposite each other. It is going to be a bit tricky to get used to, but I promise with a little bit of practice, you'll be okay. I think let's jump down to Brian and take a quick brain break. And then I'm going to let you guys try one of these proofs by yourself.
Yeah, my peeps deserve a break. Yeah, well done. You did really good. More practice is coming for you, so you'll understand better.
Okay. Let's let's see. Okay, so the first one is a mathsy one, and then there are 2 dingbats. Let's see how you go. Okay. Here's your maths one. I'm wanting to know what this word is. No takers yet.
I feel like they're busy with the calculations, so
That's
they're doing
good.
it the right way.
Yes, I'm glad. I'm glad. Calculate, calculate. I'm so surprised that no one's guessing today. That's like normally this class's go-to. Just say random words. Ah, Kupano, yes, well done. Nice job. Excellent work. Do you want to explain it to the class? You don't have to if you're feeling stressed, but if you would like to, just pop your hand up and I'll unmute you. There we go. Okay. Talk us through how you got your answer. Oh no, I can see you unmuted, but I can't hear you. Do you want to try and unplug your headphones and plug them back in? Oh, sweetheart, I can't hear you. I'm going to keep you unmuted so that if the problem resolves, we'll be able to hear you. Okay. Okay, let's move down the listy list. A P-way, can you help me figure out how to get this?
Sure, ma'am.
Okay.
So first, for the guy with the sunglasses, you're going to say 32 divided by 8.
Okay.
Which is equal to 4.
Nice. All right.
And then
so that gives us our letter.
And then for the cat spitting out rainbow, you're going to say 16 minus 4, which is going to give you 12.
Excellent. Cool.
And then you're going to say 108 divided by 12, which is going to give you 9.
Perfect. And that gives us our C, and we land up with the word 1. Nice job.
Well done, you were. That was good.
Okay, cool. Okay, we've got 2 dingbats. The one is like, well, we'll get there. We'll see. You'll see. Okay, I'm sorry it's a little bit blurry. I tried my best. This is what happens when you steal from pages. I'm trying to figure out what the sentence is. Oh, close. You're very close. There we go. Hannah got it exactly what I was looking for, because there wasn't really a the chilling here, but it is definitely standing in line. So if we have a look, the word standing is inside the word line, standing in line. So standing is literally inside line. But some of you were very close with standing in the and standing on. You were very, very close, just not 100%. Nice job. Cool. Okay, one last one, and then we're going to jump back up to proofs. I think you're going to find this one nice and easy. Split up angles. Oh, I see. Because of the yes, there we go, there we go, there we go, there we go. It is definitely a right angle because this was the only angle that was right. So it is a right angle. So the other class also said SAS, and I do see what you guys are thinking, and I like it because it's in line with congruency. But yeah, it's not SAS because they haven't told you that this is a side. But it is 100% a right angle. Nice job. Good work. I like it. And let's jump back up to our proofs. Let's see if you guys can work through your first one by yourselves. Well, sort of by yourselves. I'm going to give you a little bit of a helping hand with it. I'm not going to just throw you into the deep end. I will throw you into the deep end by the end of this lesson, but it's not quite just yet. Okay. So this is the question. I'm going to help you with a couple of things before you get going. Okay. So first of all, there's my one triangle. That's triangle. No, that's not that triangle. And there's my other triangle. Okay, so those are my two triangles. My first question to you is, what is special about angle A? Looking at this, looking at what I've highlighted, what is special about angle A? Good, good. Clo, yes, 100%. Okay. Angle A is common. So what that means, that's just a very fancy way of saying that basically angle A is in both triangles. That's what that means. Okay. So if you have a look here, that angle A is in our green triangle, and that angle A is in our blue triangle, and it is exactly the same as itself because it's the same angle. Okay, so when we're saying angle A is common, we're basically saying that angle A in our green triangle is equal to angle A in our blue triangle because it's the same angle. But we get to just write it as a nice easy sentence as A is common. Okay. Now the next thing I want you to look at is, can you say AC? We can't say AC because if we're saying AC, we're talking about a line, and we want to be talking about angles when we're in similarity. As soon as you see parallel lines, I want your brain to think of fun. I want you to see what you can find here, and I want you to see if you can fill in the rest of this for me. So I'm wanting reason 2 and reason 3. And then I'm wanting my conclusion, and then we're going to talk about this together. I'll erase it for the moment until you're there so it doesn't stress anyone out. Okay, so yes, Jasmine, 100% DE is parallel to BC, but remember, because lines are parallel doesn't mean that they're equal. So think about when we see parallel lines, what we want to be thinking about is fun. We're wanting to find angles that are the same. Good, Jasmine, absolutely. Kutwana, perfect, beautiful. Beautiful. Keep going, guys. Find your 2, find your 3. For 3, you can give me a reason, or you can take the easy route and just say sum of angles in a triangle, totally up to you. Then think about what your conclusion is going to look like, and then we'll talk about this last little part that I've just erased. And then I'm going to give you one to do entirely by yourselves.
So I got noted that Mwabi is here with us, even though I don't think he's there, but he's somewhere. Hey, Mwabi. He's with a different name, probably. That's Mwabi for you. There we go.
Mwabi, what name have you joined? Oh, yes, I knew this because I saw this name last week. Do you want me to change your name for you?
I change it, ma'am. Why?
Fine, you can stay. We know it's you. Then I feel like I should change it because that's personal information, which we don't share on the chat. Remember?
I still prefer Mwabi.
It's because don't be sad. It's because we trying to protect you. It's all protection. It's all out of love.
Yeah, and you all doing good, my pebs. I'll miss you on Thursday, guys.
Okay, I'm seeing good things here. So let's try and write what you guys have put in the chat for me. So I've seen that B is equal to D. That was, oh gosh. Okay, B is equal to D, and the reason for that was corresponding angles, and we're going to say that DE is parallel to BC. Okay, now for C, you could say that this angle is equal to that one because of corresponding angles, or you're allowed to take the easy route. Okay, so we find our last three angles that are the same as each other. So C is equal to angle E, and then we just say sum angles triangle. That's literally all we have to write. Whenever we get to our third reason, if we have proved that two are the same, for our third reason, we're allowed to just write that. We don't have to think. For the question in the chat, we're working with parallel lines. I suppose we are working with parallel lines. We're working with similar triangles. But don't panic. Remember, all of our lessons are recorded, so you can watch the beginning part of this lesson again afterwards. At the moment, we're just trying to find ways to prove that two triangles are similar to each other. Okay, once we have got that three of the angles are the same as each other, we can write our sentence. So triangle ABC is similar to triangle ADE because of angle, angle, angle. Cool. Who managed to get all of this written out? Burlington, yes, how can I help?
I just raised my hand. Like, I got it.
Oh, right. Okay, well, well done, well done, well done. Yeah. Yes, Nico, nice. Toto, yes, well done. Nice job, guys. Okay, let's look at the second part of this question now. Second part of this question says, hence. Now, whenever you see this word, I don't want you to panic. Lots of people see hence and then they go into panic mode. Hence just means use the information you have just found. Okay, so when we see the word hence, we don't panic. We just think we've just got to use what we've just figured out. So we've just figured out that these triangles are similar, which means that their sides are in proportion. Okay, so let's fill in this information. They're telling us that AD, they're telling us that this over here is 3. They're telling us that AB, I'm going to do these in the same colors as my triangles to try and help you guys out here. Okay, so AD is 3. AB is 6. And we've got AC is 8,4. And they are wanting the length of AE. Okay, So just looking at this, you should be able to see what to do. And then I'm going to show you when it's a little bit trickier. I'm going to show you a trick that you can use. But just looking at this, can you tell me what AE is equal to? Thinking about, there we go. Good. 8,4 divided by 2 is going to give us 4,2 centimeters. Good. Okay. I'm going to show you a little trick. When we're looking for our other side in similar triangles, we can write it as like a little fraction. So now, obviously, if it's easy like this, if you can just divide by 2, take the easy road, but sometimes it gets a bit nasty, and then this is helpful. So we're going to write AD, which is, I'm going to write it like this. Okay. We write it as partners first. AD over AB needs to be equal to AE over AC. Okay, so looking at those two sides, we're saying AD, that one side, over the other side needs to be equal to our one side over the other side. So we're just using ratio at the moment. Okay, don't worry, I will scroll up to give you time for screenshots just now. So I'm now going to fill in those values. So AD is 3, AB is 6, AE we don't know, so I'm going to write it as X, and AC is 8,4. Okay. This is where we get to do something quite cool. If I'm looking for X, I'm going to ask some questions here. We're going to dive into our algebra and our equation work that we did right at the beginning of the year. Who thinks that they can give me a suggestion? Yes, Nico, I didn't even have to say anything. We are absolutely going to cross multiply. That is 100% what we are going to do. Okay, we are going to take this 8,4 and we're going to multiply it up there, and we're going to take this 6 and we're going to multiply it over there. So we're going to say 3 times 8,4 is equal to 6x. Okay. Now, remember, you can do this all like on your calculator. You can do it in your head. And obviously, we know that this is going to be a nice answer. So please don't panic. Okay. So we get to this point over here. I'm now going to just use my calculator. 3 times 8,4 is going to give me 25,2, and that is equal to 6x. How do I get x to be alone now in this situation? How would I get x to be alone? What would I do? There we go. I need to divide by 6. I need to divide both sides by 6. Okay, so x is going to be equal to 25,2 over 6, which gives me the beautiful answer of 4,2. Okay, now obviously this is a way longer, more complicated way to find an answer that was very easy for us to just divide by 2, but sometimes it's not just as easy as dividing by 2 or timesing by 2 or timesing by 3. Sometimes it's a really yucky number, and in those cases, this method can really help us. We are going to be working with this method in a little bit more detail in our lesson on Thursday, but I just wanted to introduce it to you so you could see it, get an idea of it, so it's not too scary when you see it again. Okay, just going to scroll up. If you would like to take a screenshot of the whole page, you can. And then we're going to go down, and I'm going to give you some time to do another proof by yourself.
You guys are doing great, my pips. Well done.
Okay. Brian again. Okay, so now this one looks a little bit different, but it's exactly the same. I'm gonna make it a little bit bigger for those of you on your phones. Okay, remember, all you have to do is write your introduction, give your 3 reasons, say that they're the same. Burlington, what is RHS for? Is RHS for congruency or is RHS for similarity? So what we're looking here for is either that our angles are going to be the same or our sides are in proportion. Okay, so just be careful. They haven't given us any of our sides. They haven't given us any centimeters. And so when we haven't been given any side information, we won't be able to use sides in proportion. There we go. Do I have a brave soul who's prepared to sort of talk our class through this as we start? So from the beginning to the end. Ah, beautiful. Okay. Up here, where? Start this for me. What am I going to start with?
Okay, so first you're going to say in triangle ABC and triangle FED.
Okay. Great.
And for the first one, you're going to say 180. Because angle E and angle B are already given to you at 90 degrees. So if you say 180 minus 49, it'll give you 41. Then if you say 180 minus 49, it'll give you 49. So then you're going to say angle E is equal to angle B.
Okay, so if we're starting with angle E and B, all we have to say is angle E is equal to angle B given.
Okay, so that's given. Okay.
Perfect. But what you were saying was great. So if we say 180 minus 90 minus 41, we definitely get 49 degrees. Okay. So how would I write that as a sentence for number 2?
So angle F
Good.
is equal to angle A.
Perfect. And what reason would I give?
Sum of angles in a triangle.
Perfect. Okay, great. Reason 3.
Angle C is equal to angle D.
Good.
Because of sum of angles in a triangle.
Perfect. Okay. Conclusion.
Triangle ABC is similar to triangle FED because of AAA.
Perfect. 100%. Nice job of you. Tell me how this went, guys. Give yourselves a mark. 1, 2, 3. Give yourselves a mark for the introduction. Give yourselves a mark for the conclusion. Tell me what you got out of 5.